Hello, everyone. I haven't taught this information in a long time because it's been kind of sunsetted in the area of computers. We really don't do anything with this information from a technical standpoint. We don't. You can get jobs dealing with this kind of stuff, but it's very small. We put in a hard drive and the hard drive works. And basically that process is as follows. You've got a PCB, a control board that's on the underneath part of that disk, and it's got a bunch of chips on it. And one of them is, here I am, this is my specifics about what I can do. That then is reported over to the UEFI, the BIOS, and is populated there, and away we go. So we used to teach this stuff back in the day, probably a good 15 years ago. And even then we weren't using it too much. I will tell you though, I did actually use this. As a matter of fact, the first job that I ever got paid for doing tech stuff was dealing with this. So what is it and why do we need to know it? Well, this is about hard drive geometry. It's about how information is broken down to in these different tracks and sectors upon the platters. And why you would need to know that is, let's just give you an example. Let's say that there's a case going on and they want to know, they feel they have a perpetrator of, say, drug crimes, and lots of people keep that on their computers. And so they get this computer from the perp's house, but they tried to burn it, right? They tried to burn the computer before the police could get it. So they basically go to whoever their rep is that's doing this. In a small organization, like someplace around here, they would send this stuff off. And even in a medium or large organization, they may send this off. So maybe you work for the whole state of Arizona and their team of forensics investigators, or maybe you work for a place that deals with hard drive technologies and it gets sent to you. So here you got this hard disk, and everything's burnt off of it. And you know that if you try to start this up, you could just destroy all the data on it. And so what you're going to have to do is take the top of this off and evaluate whether or not this has got any kind of bending to the disk, because these are physical, or that the actual arms are messed up. And you can actually take out those disks, 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 and put them into other equipment to pull that data off. And so you start to look at this and look at this problem, and none of them seem warped. They seem like they're not going to have any kind of flaking across the material that's on that. And so just be sure you're going to put them into this other drive that's got good arms. And you have to, these are the arms, the actuator arms that have the head, the reading head on it. In any case, then you have to be able to do that in a clean room. You can't have any kind of smoke, any kind of oil, any kind of nothing that will destroy that data. So you do that, you slide it all in there. Now you need to read the data. Well, somebody who doesn't really know what's going on would just put that case on. Actually, somebody who doesn't know what's going on, they wouldn't have sent it to you to begin with. They would have just plugged it into another computer and started it up and probably destroyed it. Because most of the time, right, the only way you're going to see that data is in the operating system. So if they were using Windows, then you navigate through the files and you find the data that you're looking for. But what if none of that is working? What if that's damaged and you can't do that? You can't just plug it in. You had to transfer it over to another machine, and then you need to know some things, right? You need to know how this is all set up. And it may even be worse. You may not be able to throw it into a computer like this and get the arms to work. You may have to actually look at the disk and be able to understand what you're seeing on that disk to be able to pull off the information. That's very possible. So that's why it's in this material, is being able to do some kind of forensics investigation on it. You would need to know, this is what a hard disk is made up of. This is how it logically organizes it. So that's what you're going to be able to scan and see with a magnifying glass or some other tools to get that data off. All right, so let's just talk in general what we're dealing with here. This has a SCSI interface on it, and they're saying that it's a SCSI interface, which is most likely. Old IDE hard drives would also look the same as far as the interface goes. SCSIs are a little longer, and the newer SCSIs they use on servers have a SCA connector, so they have a whole different kind of connector on it that we're not getting into. So I'll stop talking about it. You have jumper pins, and some of those pins actually will set it in certain modes so that data can be recovered in different ways. And then, of course, you have a place you plug in power. How the hard disk is actually made up. Well, there's a thing in the middle called a spindle, right? This little tiny spindle in it. And then it's got some clamps. These basically are screwed together that hold those disks in place so they won't slide around in there. It holds them tight. And then you've got what they're terming the slider or the head or the actuating arm. That's usually what I heard it called, the actuator. And this arm reads the top of this disk, but there's a lot more of those arms. So let's jump over where I might have put that. I am not sure. We'll find it. There we are. It's more like this. You actually have a stack of these platters put together. That's what they call these platters, these disks. They call them platters. And you'll actually have a read-write arm for a head, read-write head, for every single one of the sides. The times that you don't are when basically they're selling you a hard drive and saying this has less space on it. So what they do is manufacture them all the same, and then they don't put an arm on the underside of the last one and it has less space. That they do that kind of thing. And so I believe they've got a picture in here. I think it's the next screen. There it is. And so you got this head 0, head 1, head 2, 3, 4, and 5. You know, it basically a head, a read-write head for every side with the platter stuck in the middle. That creates what's known as a cylinder. Now you can't see the cylinder. The cylinder is a combination of the top, bottom, top, bottom, top, bottom tracks. So you can physically see here that they put these. They're saying, oh, right in here in this information, we're going to make that a track. And then we're going to start another track and another track and another track and another track. Then we're going to divide up those tracks into what's known as sectors. They call them sectors, not sections, but they call them sectors. And so they're showing you that, hey, here's the track that goes around just like running track. And then here's the sector that's divided up. Now, when they divide up the sectors, they'll put a little buffer space in there. That's all engineered into the chips. It knows what it's doing. We'll get to a little of that. But again, that cylinder is something that you can't really see. What we're trying to say then is because all of these things are on an actuator arm, right? They're all connected to this assembly. The head is moving back and forth, or I should say all the heads are moving back and forth. So data is actually going to be read and written down and up, right? So it's going to be, let's read it this way. Let's read it this way, right? So that's why we talk about cylinders and the fact that when the data is put on, it's not just taking that data and slamming it across this one surface. Well, that would be kind of slow. Don't I have 5 heads here? 6 heads that I can use? Yeah. So let me push the data to all the heads. You get pieces, 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 you get pieces. Boom, 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 boom. And then the data is actually written like this, right? So it goes down like that, so that's where the cylinder comes in. The tracks, therefore, are only on the surface of that disc and then the surface of the underside and on next. And then the cylinder is created logically. That's what we should say. A logical cylinder is created. So it's important to know that. It's important to understand that, okay, that's how it's actually storing the data, because if you ever get into this area and have to deal with this, you're going to need to know that. That's the idea of the class, right? So you got the tracks, then you've got the sectors, the sectors. So this is a sector right here. That's a sector as well. This is a little incorrect, we'll put it. Right, each one of these sections is a sector. This is a sector. This tiny part is a sector. Each one is a sector. But when you start storing the information actually on the system, That's kind of guided by the format that's being used within the operating system, and it creates clusters. And when it creates these clusters, it puts them in those sectors. That's how that all works out. So that's hopefully gets you around having to be so detailed on reading the information. Now let's take a look at what some other things they want you to know. For instance, how do we calculate the capacity of it? How do we rate that capacity? What kind of interface? Like I said, SCSI here, what the interface is, how you're connecting to the computer. So what is the interface? And then the speed is done in revolutions per minute. So just like a tire, right? It's spinning around and around. How many revolutions per minute will it pass that read head? This read write head goes back and forth across that. So it can read every portion and write every portion of that disk as it spins, or the cylinders as it spins. Then you've got seek time, access time, and transfer time, which are all just a little different. So let's take a look. I'll show you something that deals with the track numbering, but a really important part of that is that on a hard disk, it begins at 0. From the outer edge, it moves towards the center. So we'll start on the outer edge and come inward. Why track 0 is so important is because that's usually where the boot sector is put. So if a computer wants to boot up, it'll look at that. You can actually just destroy that little tiny section, and then the whole computer won't boot, even though all the information is still there. And then we already talked about the read write and the arms moving back and forth. And we talked about the cylinder. All right, so each sector normally contains about 512 bytes. And when you look at that, that's super tiny for us. That is really, really minuscule for us. You're really saying, okay, I'm dividing this up a lot, right? I'm going to make these sectors really, really small. And back in the day when we were dealing with very small files, that was good. That was very good. Windows NT, New Technology File System, or NTFS file system, gosh, that's been around a long time now, and I can't remember what version it is, probably 3 or 4, but they started creating clusters this big. So 4K clusters, which is still for us, right? That's really tiny. Even though a text file that's only got a couple of lines of data is only going to be like 128 bytes. It's not going to be that big. They break it down into 4 kilobyte clusters. And so that gets us in a situation of why not make that a little more equal than it is. So anyway, moving on. So when you're actually storing that information in the sectors, what do you have? Well, you have the data, right? The data that you're actually trying to put there and store, your game or your video or whatever it is. But you have to have a way to pull that information in and off. So you have to have some way to identify it. And you have to have some way to have this all formatted so it can be found. It's sort of like saying a farmer goes out and says, you know, I haven't used that plot of land out there. It hasn't been used in about 50 years. It's got mesquite trees growing in it. It's got no rows. It's got no ditches to it, but I'm going to use it, right? So there's things that he's going to have to do to make that a usable field. He's going to have to make rows in it. He's going to have a delivery system for the water in it. He's going to have to figure out what is the size of the plot. Because if he just throws seeds out there, we're not living in Oklahoma. They're not going to grow. And if they do, it'll be really, really, really small growth. You won't have any way to get water to it. So it's a good chance it's all going to die, right? Takes some preparation. That's what we're talking about here. So the ID information, that part contains the sector number and the location. So we're going to say it's sector 17. This is its physical location of it. Then you're going to have the synchronization fields. The drive controller drives the read process using those fields. So being able to synchronize that data. Error correction, just in case we had something wrong. So there's error correction code in there to make sure the data has integrity. And then there's gaps used between them. And we talked about that. So they actually have, I believe, yeah, they do. So they actually have those sectors kind of broken down. So when they break down a sector, this is usually what it's sector, 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 right? That's the way it's broken down. But now a lot of the newer drives are doing this 4K byte sector, just one whole sector. The ECC information is going to need to be bigger. You're going to have your gap, right? So you're using up better space for the gap, and then you're using better space for the sink and the address. So you're getting more out of the space of your hard disk. You're storing more information in that. And it can also be distributed with that ECC. Now, some hard drives really don't have ECC, but they're putting out that, a lot do, and that's how it actually works. All right, so this is what's happening. Sector addressing. Cylinders, head, and sectors determine the address of the individual sectors on the disk. And I think, did I skip that calculation? There's a calculation for that. Maybe it's even one more back. I think it's here. Oh, no, I guess it's not. So we'll get to it. But there's actually a calculation. And as I said, the first thing I did as a tech that I got paid for, right? Not helping family just for kicks. I actually got paid for this. This person got my name from the college. And so I went over to help them out. And I didn't know anything about how a BIOS functioned, how CMOS works, how the hard drive has to be set up. Most of the operating systems I'd used before that, they did all that for you. And that made all that stuff really easy. Well, when you get to DOS, you get to the Windows side of things, there's so many options, so many makers of hard disks that mainly what the BIOS manufacturers would do, or your UEFI, which did not exist, the basic input output system, you'd have to type in all that. And so it's very common that the hard drive would have on the top all the dimensions you needed to tell it what was going on. So I'll get back to that story in a minute. So track density, that's actually calculating space based on the track. How much information is in that track? And the areal density is actually looking at, well, a square inch on it. If I just look at it, like there's a platter, right? How much space is on there? And then, of course, bit density, that refers to the number of bits in a unit length that the actual track can accommodate. You have a CHS, which is cylinder head sector. That's what we're talking about. Yeah, it's right here. Geez, it's right in front of me. And then I went all over the place trying to find this. Anyway, so CHS is calculation that you can do, and it is dependent on the geometry of what's happening. For instance, how many cylinders are there on this drive? How many heads are there? How many sectors per track? And we're going to assume 512 because that's the old standard. So what you do to find out the total size of the disk is you just take the number of cylinders, multiply it by the heads, multiply it by the sectors, multiply it by 512 in the sector, and look at that. You end up with the end of that. These days, it's hard to find drives that actually have all that. This has got 80 heads, and this has got 63 sectors or 64 sectors. This one's 512. It's very hard to find that these days because we don't use that. But it's important for you to know that it's there, because again, if you are in that situation where here's this thing and you got to take it out of a drive and put it in another one and start reading it, and then you realize that doesn't work, and now you got to start looking at it, you need to know what you're looking at. And so that's what the CHS does, is just that calculation. And that's what I had to use. So me and this lady, she was really smart. Her battery had died. So she lost all her BIOS, and now nothing is accessible on the computer. Like that's going to freak you out, right? You bought this $1,800 computer, the battery goes dead within a couple of months, and now all your data is gone. Not good. So I took out, she said to me, so, to be honest in everything that was happening, she said, well, I know that it goes back to this thing, right? When the computer starts up, it doesn't find the hard drive. And I was like, that's interesting. I'd never heard that, right? All that stuff on other systems is usually just baked into the ROMs. And so you can't really change that in the old systems. And I hadn't had any experience in Microsoft, not Microsoft, but IBM stuff back then. And I didn't know how that all worked. And I was like, oh, that's interesting. So we got the book. Every computer that was built back then, unless you bought an IBM, right, which was really expensive, had a little book that told you about how to do things in the BIOS. Not a lot. It's not like it was a book and told you all the details. It didn't. It was just this little pamphlet. So you open up, get to the section on the hard drive, and oh, you need to know the geometry of the hard drive. oh boy, how do we figure out the geometry of the hard drive? Well, thankfully, I didn't know this, but we opened up the computer, look on the top of the hard drive, and there it is telling you how many cylinders, heads, and sectors, and not this many, right? It was not that big, that it had. And so we went in, we wrote all that down, and then we went into the BIOS and we put that information in where it needed to be, saved it, restarted, and the system came up. I cannot tell you how grateful she was. I did not charge her much. She kind of like forced me to take payment because I was learning it, right? I was like, I'm glad that worked, that kind of thing. So that's how you deal with the size. Now, the other part of this that really is not super applicable to what you're going to do, but it's good to know that it's there, is how fast is a hard drive and how is that rated? All right, so the total access time, right? Notice this is the heading. Depends on the mechanical nature of the rotating disks and the moving heads. So we say, I want to access data off of that hard drive. Well, how long does it take to do that? Well, let's break it down. There's a seek time. That is, that little actuator has to get over to where the data is. And that's a combination of how fast does that actuator move and how fast is the disk spinning. Again, we're going back to RPMs. And that's why a lot of low-end notebooks are really, really crap, because they have a hard disk in there that's only 5,200 RPMs. And the hard drives that you would put in a nice system are 10,000 RPMs, twice as fast. So you're talking about the seek time being less and tremendously the faster that rotates around. And then, of course, the rotational latency. Latency means what is the gap between I asked for it and the data is actually saying I asked for it, and the arm moves and the disks spin. And that's the latency. The average disk rotation latency is half the time taken by the disk to complete one revolution, right? So why would you do that? Why is that a thing? That's the best way to put it. Why are we talking about this? Well, it's a matter of most hard drives, unless they're server drives, do not sit and spin. They don't just sit there going at 10,000 RPMs all the time or 5,000. When you're on your notebook that has a hard drive, heaven forbid you have one now, right? Make sure it's SSD. And you say, oh, I'm going to go get this file, and you move the mouse, boom, let's grab this file. It goes spin, right? And so we're dealing with the average disk rotational latency that's not really the same as the RPMs. And then you have the data transfer rate. And that is really like, well, I'll just read it. It's expressed by the internal rate at which the data is transferred between the disk surfaces and the drive controller, as well as the external rate. So let's take all this access time. Let's also add in how long it'll take the data that's now found, and now it needs to go over to the CPU. How long does that take? And so this is how it, IDE is really old stuff. They talk about SCSI here. I'm not sure why SATA is not in here. IDE, we don't even use that anymore. But data transfer rates of your inner zones on the hard disk range between 44 megabytes. This is one of the things I don't like. Almost everything is rated in megabits when you're dealing with networking and so on. Even in RAM, it's megabits. And here it's bytes. And so there's a conversion you'd have to do to find out how many megabits of speed that is. And remember, there's 8 bits per byte. So it's not just let's move over a decimal point, right? And then the data transfer rate and the outer zones, right? Because it's larger out there and it's smaller in the middle. And that is really what you need to know about hard disks and how they work. And in class, I'll actually show off one of these. This will actually be, when I do these little things, this is stuff I'll be talking about in class. But I know that some people want to refer back, and it's a lot easier to do it in a short video. And I also know that, I've got people that aren't in class, and it's easier for them to look at this than something that's, much longer. All right, the next one we'll look at solid state drives.